All right, let's look at the mixture problem. All right, let's say we have a 120-gallon water tank, and initially we have a 90-gallon of salt water, and it has 90 pounds of salt initially included. All right, and then what we want to do is we're going to pour the solution, 2 pounds of salt per gallon at the rate of 4 gallons per minute, and drain it out at the rate of 3 gallons per minute. All right, so since we're pouring in faster than draining it out, the water level will go up. In this case, 4 minus 3, so 1 gallon per minute. So the water level is going up at the rate of 1 gallon per minute. All right, so eventually it's going to reach the 120 gallon point. So it's going to be 30 more gallon. It's going to be full. And what we want to do is we want to see how much salt is going to be present when the tank is completely full. All right, so let's do that. All right, so here's a notation. S of t is the amount of salt in pounds after t minutes. All right, so what we want to do is we're looking for S of 30 because it takes 30 minutes to for the tank to be full. All right, so to do this problem, we're going to set up a differential equation. So let's think about the derivative, so rate of change of the amount of salt with respect to time. All right, then what we can do is we can probably think of it this way. So we have to find out the rate of salt that's going in. So here I'm gonna call it rate in, and then we have to think about the rate of salt going out. So I'm gonna call it rate out. All right. So rate in is usually easier. So the solution is 2 pounds per gallon, and it's poured at the rate of 4 gallons per minute. So we can just multiply these together. So it's going to be 8 pounds per minute. So this is going to be just simply 2 times 4. All right. Rate out is going to be a little bit tricky because the solution, the amount of salt in the tank will be constantly changing. So amount of salt at time t would be S of t. Right? So amount of solution is going to be, so you have 90 gallons to begin with. Then it's increasing at the rate of 1 gallon per minute because you're pouring in at the 4 gallons per minute, draining it out at the rate of 3 gallons per minute. So the difference is 1 gallon per minute. So it's going to be, after t minutes, you're going to have 90 plus t gallons. All right, so this ratio gives you the concentration, right? Pound per gallon. Then you are draining it at the 3 gallons per minute. So what we're going to do is multiply by 3. So what you get is going to be, so rate out is going to be 3 times, 3 over maybe I should say, 90 plus t, or t plus 90, doesn't matter, and times S. All right, so we have that equation. And if you look at the equation, this equation is actually a first order linear equation. So we can actually solve this one. All right, so let's clean it up so that we can see it better. And I'm going to put this term over to the other side. So I'm going to add 3 over 90 plus t s. So you're going to get ds over dt plus, right? So this is going to be added. So it's a 3 over 90 plus t s, which is equal to, right, 2 times 4 is 8. All right, so this is the equation, and you can see here this is going to be our p of x, and this is going to be our q of x. And we also have initial value condition. So capital S at 0, it's going to be, since you have a 90 pound of salt present initially, so this is going to be S of 0 is equal to 90, right? So we have initial value problem here. All right, so let's use integrating factor. So integrating factor would be, all right, I'm going to call this I, all right? So it's going to be e to the integral, right? P of x is 3 over 90 plus t dt, right? So if you do that, you have a e to the, right, 3, I'm going to pull it out, and 1 over 90t is going to be natural log of absolute value of, we don't really need absolute value because this is going to be never be negative. So I'm going to do that, right? And then we can use the log property. So you can place this guy up here. So I'm going to scratch that and then put 3 there. Right, then we can cancel e and natural log, cancel out. You're going to end up with a quantity 90 plus t cubed, right? So this is the integrating factor, right? So using that, we can have s is going to be, right? Remember, it's going to be 1 over I, which is quantity 90 plus t cubed, integral of q of x, in this case just 8, times I, which is 90 plus t cubed with respect to t. All right, so finding the antiderivative, so it's a 1 over 90 plus t cubed. All right, so antiderivative of this guy is going to be, let's see, maybe I should use a bracket here. All right, you have an 8, so that's just a number, and add 1 to the power, so it's going to be 90 plus t to the 4th power over 4 plus some constant c. All right, so you can cancel. There's a 4 and a cancel out, so it's going to be 2 there. So if you clean this up, you're going to get this. So you have a 2. Right, so if you do, let's see, 90 plus t to the 4th and 90t plus over 3, so they cancel out, you're just going to get then 90 plus t, right, and a plus, right, so you're just going to have c over 90 plus t cubed, right? So that's the s function that we have. And then we can use the initial condition, s of 0 equals 90, to find the c. So let's find that. So s of 0 is equal to, all right, so it's going to be 2 times 90, so it's going to be 180, right, plus c over, we're going to have 90 cubed, so 90 cubed, right? So this is going to be equal to, all right, and it has to be equal to 90. All right, so first I'm trying to solve for c. So subtract the 180, all right? So you're going to have c over 90 cubed is equal to negative 90 minus 180 is negative 90. All right, then we can just multiply through by 90 cubed. All right, so c is going to be negative 90 to the 4th power. All right, so we found c. All right, so therefore we have s of t. So we have a complete formula, which is 2 times 90 plus t minus 90 to the 4th power over 90 plus t cubed. All right. Doesn't look very pretty, but we have the S of t function. Then what we want to do is we want to see the amount of salt in the tank after 30 minutes, because it takes 30 minutes to for the tank to be full. So we just have to find the S of 30. Right? So this is going to be, right, so it's 2 times. All right, so put 30 there, so it's going to be 120. So 2 times 120 minus, all right, so you have a 90 to the 4th power over, again, this is the same thing, 120 cubed. All right, so let's find this value using a calculator. All right, so we need to compute 2 times 120. I can do that. It's a 240, right? So 240, and we want to subtract. So we have a 90, raise it to the 4th power, and then we're going to have to divide it by, and 120, raise it to the 3rd power. All right, so let's hit enter. All right, so it came out to be about 202 pounds. So 202 pounds. All right, so we have that. Let's see, I'm going to just box it out here. All right, so at the when the tank becomes full, which is 30 minutes later, the amount of salt will become about 202 pounds. All right, that's it. I hope that this was clear.